This video describes the production of these two segmented eyes made from honey locust. This video describes the production of a different style of this dizzy eye that I just completed, but instead of using this dizzy pattern for the eyeball, I'm going to use a segmented ring consisting of this piece of honey locust, which should give a nice contrast to the iris and be a little less busy than this dizzy pattern. So the plan is to take this piece of honey locust, cutting it into strips, ½ inch thick, and then I'll be making between 8 and 10 layers of segmented rings. Each ring will have 18 segments per layer. Should take about 8 to 10 layers to complete the eye. And then I'll turn it in the lathe, drill a hole, and insert my iris. And then we'll have a second pattern of this project. So let me start by turning these boards into some segmented rings. Okay, I'm ready to start making the segmented disc for this project, and I did design this in the Woodturner Pro software. So I'm making a round sphere, which is about 4 1/4 inches in diameter, and I'll have 8 layers, each layer being ½ inch thick from this honey locust wood. And so for these center layers, I'm making these center layers first with an outside diameter of 4 inches, and my board here is about 1.2 inches wide. So each of my segments has a width here about 0.75 inches. So it's all been set up with my Accu-Stop, 0.75 inches. I put my line on my board so I can get my alternating disc. I have my laser beam on here so I can see exactly where I'm cutting. And in cutting these segments, I kind of stressed this in previous videos. First of all, my jig is set to 18 segments on both the fences. And it's very important when you're using the Accu-Wedge that the board is tight against the fence, tight against the table, and center. I usually try and center my point right in the center of my Accu-Stop. Also, my board is perfectly straight and parallel. I ran these through my board sander both directions, this way and this way, to give me a nice straight board. Because if this board was warped at all on here, you're liable to get some error. So it's important to have a nice straight edge, at least on this one edge. It needs to be very straight. But again, you have to put it in here against the table, against the fence, and you have to clamp it down. It's very important to just get clamped, because if it's not clamped, the board will move. Since you're cutting at an angle across the grain, holding it up by hand, that board will move and you won't get perfect wedges. So it's very important that that board be clamped in position. So I adjust my clamps for every type of board I change. I get this, push it, put it in the middle of my Accu-Stop. Even though I try and get my Accu-Stop perfectly flat, it could be off a hair. So by positioning my board in the center all the time, I can minimize any chance of it being off. So now I'm ready to start cutting my segments. This video is sped up 5 times the actual cutting speed for viewing purposes. And I'm using a 3/4 inch wide blade, 14 teeth per inch. So now the next step will be to take each of these segments and to sand the fuzzies off the edge, because there is some fuzzies where it kicked out the edge of the bandsaw. So I'll run those fuzzies off to clean them up with some like 220 grit sandpaper. So the next step is to start sanding these segments to get rid of the fuzzies. And there are some fuzzies on the edges and a burr here where it kicked out the edge of the bandsaw, so those need to be sanded off. But just lightly sand the edges and corners, no significant sanding on these surfaces. And I'm using the 220 grit sandpaper to do this sanding. What I usually do is just a couple slices, rotate it 90 degrees, and just keep doing that for all 4 sides. And then get the edges. And that cleans it up nicely. You can see the results. Like here's the before and after. And there we completed 4 discs here, which are all assembled. Let me just keep going here. And I get my lines on here and purpose of these fines is to keep everything oriented and then rotating them so they rotate or alternate back and forth. And then after they're all sanded, I'll put a rubber band around them to check the alignment. And that's the resulting ring. For the top portion of this round sphere, I need 18 pieces or segments going to a perfect point in the center. And this is probably the hardest cut to make on the Accu-Slice system. You know, getting a perfect point on the edge. Because if you go cutting here, if you go too far to the outside, the bandsaw blade tends to ride the surface and curve out and you get an imperfect circle. If you go too far this way, then you get a hole in the center. So it's a real close tolerance between the two. One being, too much and you get imperfect matching wedges when you make your circle, or you get a hole in the center. So it's a real close tolerance. And usually I go by feel. I push my board. I already cut my one surface on the board. I got my board clamped in place. And I can go here and I should be able to just feel the teeth on the edge of the bandsaw on the side. You know, if I don't feel the teeth at all, then I'm probably too far this direction. If I feel too much teeth, then I'm too far that direction. So it's real close. And in some cases, you may want it to get a little bit of a gap or a little bit of a not point on the edge and then sand it flush. You can always do that also. But I prefer if I can cut it to a perfect point. But it's pretty close to do this. It's real close. And I can kind of tell when I cut these, like I cut this piece off, and I match the edge, and I look at my edge here, and it's pretty much right on. So I think we're okay on this. So let's try making 18 of these and see how they come out. So again, it's the same process. I have my Accu-Stop all set up. And because it's such a close tolerance, I make sure I get exactly in the center of my Accu-Stop every time. And make sure my board is clamped down real tight. Okay, let me take these pieces next and I'll sand them. I'll get rid of because you still get a burr on the edge, on some of these. On the pieces where you get a burr on the edge of this point, you want to cut these real slow because you don't want that chipping out. So when I'm cutting it on the bandsaw, I cut real slowly. And then when I sand it very carefully. Because if you don't, this is what happens. See the chip in there? And that's because I sanded it too aggressively. So I sand very slightly and smoothly just to avoid any chipping out. The other thing in cutting these segments, if you're going to make these go to a perfect point, start with making 8 segments per ring. The more segments, the harder it is to do. This particular ring is going to have 18, which is pretty much the most I've ever done. 8 is pretty easy to do. 12 works pretty good. When you get to 18, it gets very difficult. Okay, I did want to show the sanding of this burr on this pointed edge. It's quite important when you sand this off, you sand it and you don't chip it off. If you chip it off, you can chip a corner out. So I want to lightly sand this, very light pressure, sand it down a little bit at a time until the burr is gone. So just very light pressure. So you see it's starting to wear away. As it gets down further, then you can increase the pressure because it won't chip out. As a result, you get a nice sharp point on your wedge. So that cleaned up pretty nice there. But the secret is very light, very light pressure when you do the initial sanding. Let me show another one here. Again, nice burr on that. Now the burr's about half gone there, and it's not chipping out. So what happens if it chips out, it can actually chip in the corner out or take a chip out of the center. And again, it's a near perfect point on there. Now the other pieces where the burr's on this edge, there's no issue with that. You can be more aggressive in sanding that off, because it's not going to chip out the tip. Anything going to chip is going to be these with the the burr on the tip. They're the ones that are going to chip out on you. Here's the resulting segmented disc going to a near perfect point. There might be a tiny pinhole in the center, but it's near perfect. And here's the opposite side. I have my segmented disc all ready to glue up. I have them all organized here. And I made a jig here. This is just a piece of plastic, the exact idea of my center. And that just makes it easier when I'm clamping. It keeps everything circular so it doesn't get out of skelter. And I am using Type-On 3 glue for this glue up. So let me get started here. Get my jig here. And we'll start gluing up. And I'm putting glue on both sides of these wedges. After applying glue to the last segment, I then put rubber bands around the assembly, putting multiple rubber bands to tighten it up, and then using that center block to make sure I keep everything in a nice circular pattern. Okay, take that out. And here's the first one done. Next I'm gluing up these pieces to go to a point in the center. And this is the resulting finished glued up segmented disc. And now I finished gluing up the rest of the segmented disc in the same manner. Okay, my discs are all glued up. Now I'm going to run these through my board sander to get rid of the excess glue and level the surfaces. And pushing these small pieces through my drum sander, they're pretty small pieces and I'm concerned they get hung up in there and just get a big groove in the middle. So I do use a stick, which is thinner than my board, to push them through to make sure they don't stop any way through, and I should get them nice and flat. Next thing I like to do is just clean up the edges. And I usually use my belt sander. And the idea is just to get the glue off the surface and around the edges a little bit to see more what it's going to look like as I assemble it. You don't need to do this. You could just as easily glue these up right on the jig and without the edges being sanded. But my preference is just to sand them ahead of time and see what it's going to look like. I'm using my belt sander. I could use my disc sander. I prefer not using the disc sander because it runs too fast and it tends to burn the wood, so this will not burn the wood. So let me just ground these corners off. And this is the finished segmented disc, ready for the next step. Okay, I have my pieces all set to assemble these round balls to make these eyeballs. And I did cut enough segmented disc to make 2 of these eyeballs, all out of this honey locust. And I have my bases ready. I have my face plates with the sacrificial board on it, so these are ready to start gluing up. I have a couple of choices for base. I was either going to use a padauk, or I have this piece I made some time ago with alternating padauk, cherry, and walnut. I could put on a base. So I'm thinking of using both of those. Now I'm going to make these 2 eyeballs slightly different. This one I'm going to make solid, nothing in it. But this one I was thinking of putting this piece of bloodwood in the center. It's a thin disc, about 1/8 of an inch thick, just to give it a contrast. And then my iris will be like in the center. So that might be different. I'll try that out. So just to be a little bit different. And this kind of matches, this too. I think that'll look good. So I'm ready to start assembling these. So I have my base pieces. And then I'll have these 5 middle layers. And then my top layer. Glue my top layer with my segmented piece going to a center point. So that's all set to start gluing up. I've shown this in the past. This is my old jet lathe, which I used to use, but I now use my new Powermatic for all my turning. But I do use this lathe for a lot of my glue ups. And I mounted my faceplate on the headstock, and on the tailstock I have a rotating wheel, and I put my piece of padauk, in this case, in my chuck, and that keeps everything centered as I glue it up. And once again, I'm using Type Bond 3 glue. And let that dry for an hour or 2. I've used different techniques over the years to glue up my segmented discs. But today I'm going to be using my glue jig here. And I like this jig because, number one, these posts keep the disc centered. So when I put multiple layers on, they don't slip and slide. You can tighten them up tight against it. And then I have a piece that goes on top with a clamp, and that clamps them and clamps them down, so I don't need to press. So this does everything. It centers it, and it presses them together while the glue is still drying. So I have these set, I have these loose, so I can put my piece in and then push these up against tight. So let me start the glue up. And once again, I am using Type Bond 3 glue. I apply glue to both sides of the disc and then put them in the glue up jig. And then after adding the second segmented disc, I tighten up my clamps so that everything is tight to keep them aligned. Put my spacer on top, glue it down, clamp it down, push out the excess glue, and then let that set for at least 15 minutes. Okay, now I'm ready to glue on the 3rd layer. Once again, I like to loosen these clamps just so it slides on easier. I continue adding the layers, the 3rd and then the 4th layers. And you notice that as much as possible, I try and keep my disc with the same OD diameter. That again makes it much easier to use my glue up jig to get the alignment accurate. The ID can change, but I try and keep my OD the same for as many pieces as possible, with the exception of the very top and bottom, which of course are smaller discs. Now what I normally do between layers is I usually sand this surface to make sure it's perfectly flat. Sometimes it seems it moves a little bit, so I just put some pencil marks on there so I can see it. And I have a board here with some sandpaper on it, which is perfectly flat. Okay, I'm ready to glue on the next layer. And my disc here only 1/2 inch thick, so I'm using my chuck here. It actually sinks the whole way in, so I put a spacer here, which is about 1/8 of an inch thick, so it sticks out about 1/8 of an inch so I can see the alignment of the various segments. Again, I'm using rotating tail stock. And once again, I do put the Titebond 3 glue on both surfaces to be glued, just to make sure I got good contact in between the pieces. And then by putting the pieces in the rotating tailstock in the chuck, when I clamp them together, both pieces are perfectly aligned with one another. And just make sure I have a good tight glue joint the whole way around, which I do. And let that dry for about 15 minutes, and then I'll glue on my four sections. Now I do like to sand after each layer is glued on for two reasons. One, to make sure it's perfectly straight, that the glue hasn't caused it to bow or anything. But the other issue is if the pieces start to skew a little bit here, because maybe the board's not perfectly straight, and as you keep doing it, it'll keep getting more and more out of the line. So if I sand it every time, it'll stay perfectly flat and it'll keep everything nice and straight. So let me give this a quick sanding. And that was perfectly straight. There was no issues there at all. So now I'm ready to put this piece on. It'll fit on my chuck here. So let me glue both surfaces. Okay, I have a nice tight glue joint, glue seeped out of all the crevices there. So let that dry for another half an hour, and then I'll put the final two layers on. In the same manner, I add the final two layers to the assembly, sanding each layer between glue ups, putting my layer in my rotating chuck, clamping in place, and then double checking the alignment, making sure my joints stagger one another. Then I let the assembly dry for at least 3-4 hours. Okay, I'm now ready to start turning my eyeball. I have it mounted on my lathe. And to get my perfect shape, I just have a simple template. This is just in this case, a 4 1/4 inch diameter oval. And I use that to keep the symmetry correct. And again, I'm using a carbide tooth chisel. I'm showing this video here at 10 times the actual turning speed, just for viewing purposes. I'm actually cutting quite slowly to get good results. The lathe is rotating about 1600 RPMs, and I like using these carbide cutters for doing this work. It seems to work best on these segmented pieces. Here I'm changed to another carbide tool with a more pointed tip to get into the small area between the ball and the base. To make the bead on the base of the assembly, I use one of the D-Way beading tools. I finished by sanding, starting with 100 grit sandpaper and sanding all the way down to 400 grit. Well, that's the eyeball complete. It's been sanded down to grit 400. And next thing we to insert the iris. So I'll take this to the drill, and we'll drill that and insert that. In the same manner, I turned and sanded the second eyeball on the lathe. When I made the dizzy eye, I drilled a hole for the iris on my drill press. And I had a lot of movement, just because the drill press isn't as precise as this machine. And this is my metal mill, which I don't normally use for wood. But I wanted to mount this on here because everything's more stable. I actually mounted my eye right in the chuck in a rotary vise, which is bolted to this table right on this metal mill. And I put a little support on here to give a little additional support so it doesn't move. I aligned it this way, so it's right in the center this way. And now I have it aligned right over the center of my band here, so it's right in the center. So it's perfectly straight, and there's no vibration. It's a much more stable system. So I should get a lot nicer hole for this iris. So we're all set to start cutting now. I'll be cutting this at around 500 RPM for this. It's a 2 1/8 inch Forstner bit. And you can see we have a perfect hole in there. And it fits nice and tight, no gaps around the outside edges. That is perfect. Using the same process, I drilled a hole in the second eyeball for the iris. The iris is then glued into the eyeball socket using Type-On 3 glue, and then it was sanded so that it protrudes above the surface of the eyeball by about 1/8 of an inch and sanded smooth. This video describes the production of these two eyes made from segmented honey locust. Again, there were 8 layers of segmented honey locust, 18 segments per layer. After the iris was inserted and sanded smooth, they were given about 20 coats of wipe-on high-gloss polyurethane. The base for the eye on the left was made from segmented padauk, again 18 segments per layer. The base for the eye on the right was made from 18 segments of alternating walnut, padauk, and cherry. This eye also has a center band in the center of the ball, which was made from segmented padauk. After I finished the 2 honey locust eyeballs, I made these 2 additional eyeballs made from segmented hickory wood. Again, it was 18 segments per layer, and there were 8 layers in each of these eyeballs. The eyeball on the left has a single padauk band going around the center, and the eyeball on the right has 3 bands, one wider band in the middle and then 2 thinner bands above and below that, just to give some additional detail to the project. And again, both of these eyeballs have padauk bases, again 18 segments per layer. These are the 6 Dizzy and segment eye projects completed and concludes this 3-part video series. If you have any questions, concerns, or comments on this video, please give us a call or drop us an email. We'd be happy to talk with you. And once again, thank you for watching this video.